Hello everyone, in this class we will talk about the storage class. A storage class actually defines the scope and lifetime of a variable in a C program. This is the definition for storage class. Actually it is talk about the scope. Scope means the visibility, and the lifetime. Lifetime means the span of variables in a C program. It actually tells from which part of code we can access a variable. So, based on this, a storage class is used to describe the following things. We can say it actually defines the scope of the variable, the physical memory location of the variable, the initial value of the variable, the lifetime of the variable. So these are the things that can be defined using a storage class. And in C, we have four types of storage class. They are auto storage class, external storage class, static storage class, and register storage class. And the use of auto storage class is actually it is a default storage class. Auto is actually a default storage class. That means if we don't mention anything, the variable will be treated as auto storage. And the next one is external. It is a global variable. And next one is the static one. It is actually local variable which is capable of returning a value even when control is transferred to the function code. We have seen the case of functions. And next one is register variable. It is a variable which is stored inside a CPU register. We will see all these four storage classes in detail. The first one is auto storage class. The variables defined using auto storage class are called as local variables. And this auto stands for automatic storage class. So a variable is in auto storage class by default if it is not explicitly specified. And the scope, coming to the scope of auto storage class, the scope of an auto variable is limited with the particular block only. Block means a group of statements that are written inside double brackets like this. The group of statements that are written inside the double brackets is called a block. So the scope of an auto variable is limited with the particular block only where it is defined. Once the control goes out of the block, the access is destroyed. That means once the control goes out of the block, the variable will never exist. The access is destroyed. This means the only block in which the auto variable is declared can access it. So wherever we define, we can access auto storage class only in that position. Consider this example. It's a simple program. And in this case, we have only one main function. And I defined three variables: j, again j, again j. For a beginner, it may seem that j, only one variable I have defined. Actually, I have defined three different variables. Even though the name of the variable looks like the same, the variables are different. In this case, auto int j equal to 1, that is actually defined in this block. And this one is defined in the inner block. And this variable, it is defined in this inner block. And we will print out that result. So printf %d j, which value you will get, whether we will get 1, 2 or 3. As the answer, we will get the output for this printf statement, we will get the output 3, because j is defined in this block where this one is visible, others are not visible. Okay, and if you print outside this block j, then what will be the result of this printf statement? This will give you 2. The output is 2, because this j, the value of j is actually in this block, it is 2. Okay, and similarly for the third printf statement, you will get the value as 1, which is defined inside this block. Okay, so that is all about the auto storage class. Now we will see the next category, which is external storage class. Extern actually stands for external storage class. Extend storage class is used when we have global functions or variables which are shared between two or more files. That means extend storage class is used when we have global functions or variables which are shared between two or more files. That means if we want to share variables or data within the program or within the different files, we will use extend storage class. So keyword extend is used to represent the extend storage class. So it's a global variable. Global in the sense it can be accessed anywhere in the program, or function in another file. That is also possible. If you define a variable as extend, you can access it in another file also to provide the reference of variable or function which we have already defined in the original file. We will see one example for this. Before that, the variables defined using extend keyword are called as global variables, as I said, and these variables are accessible throughout the program. And see this example. Main, this is our main program, and we have another file which is called support.c, and this is defined inside another file, and this is defined inside another program file. So if you look at this main program, here you can see the extend keyword. Here I have used write extend, which is a function. That means this particular function is external to this main.c. But that means if you look at the program, we haven't returned the definition anywhere in this program. So, but we are accessing that function. We are calling that function write extend. Okay. So if you look at the support C definition, this is another program file where this extend write extend, this function is defined. You can see this function is defined here. So what is that? Printf count is %d count, and here extend in count, you can see another extend variables which is defined here. Okay. So here inside the main program, if you look at the main program, in the main program I am initializing this count variable with a 5, and we are calling that external function. So what will happen when this function is called? This extend in count will tell the compiler that this variable is defined in some other file. Okay. So the compiler will refer this particular file. Okay. So from there it will get the value for this count variable, and printf will print that 5. So that is the case of extend. So the extend modifier is actually used when there are two or more files sharing the same global variables or functions. So whenever you want to share data between different files or between different programs, you can use extend storage class. That is the main use of extend storage class. Next we will see static storage class. The static storage class instructs the compiler to keep a local variable in existence during the lifetime of the program instead of creating and destroying it each time it comes into and goes out of scope. So it's actually a local variable. From the definition you can see it is a local variable. But what is the nature of local variable? Whenever we leave that block where the local variable is defined, that local variable will be removed from the main memory. But this static storage class is not like that. Even though it is a local variable, that will remain in the memory. How long? During the execution time, during the lifetime of the program. During the lifetime of the program, the static variables will remain instead of creating and destroying it each time it comes into and goes out of scope. Therefore, making local variables static allows them to maintain their values between function calls. Therefore, making a local variable static allows them to maintain their values between function calls. We will see one example. So this actually shows an example where we have a main function and another function defined. These are the things that I have defined. So inside this program, if you look at this program, you can see a static variable, and the name of that static variable is count, and it is initialized with a value 5. And in the main program, we are actually decrementing that value, and then we are calling that function. So inside the function we have defined another static variable with a value 5. I++, we are incrementing it. So first time the count value is 5, and then we are calling this function. So what will be the value of this I? So it will print I is %d, and so it will print, so we will see the output. It will print I is %d means here it is incrementing 6, and count is %d I count. Okay, so what is the value of count now? 5. So while count 5, so that will be printed here. Okay, so this will continue. Anyway, whenever this function is called in the next time, the value of I will never get initialized to 5. It will remain in the previous value. That is the beauty of static storage class. So remember, the static variables has a default initial value 0 and is initialized only once in its lifetime. So these are the 2 points that you should remember. Static variables has a default initial value. If you are not mentioning any value, the default initial value will be 0 and is initialized only once in its lifetime. That is the 2 properties associated with static variable. This is another example, and it will show you the output. So here main program is there. We have a counter 7, and we have function call is there next. So counter less than 10, yes, it is less than 10. Counter plus plus, and then before this counter plus plus we are calling this next function. Inside this next function we have created another variable, static variable, iteration with a value 13 initialized value, iteration plus plus, and then we are printing it iteration %d, that means plus plus. So now it is 14 and counter value is actually 7. So this you will get the printout as iteration equal to 14 and counter equal to 7. So it will come here. After this execution, it will come here counter plus plus. So now counter will get a value 8, and int iteration it will not get initialized again. What is the value now? 14. So iteration plus plus means it will get a value 15. So iteration value will be 15 and the counter value will be 8. See, so this is the output, second iteration, and in the third iteration it will get a next value. So you can see in this one, even though we have initialized it in the function with 13, every time when the function is called, it will not reinitialize. The program will never reinitialize. It will remember the value that is in this iteration variable. Okay, that is the beauty of this static variable. Next one is register storage class, which is the last one. The register storage class is actually used to define local variables that should be stored in a register instead of RAM to have quick access to these variables. All the storage classes that we have defined earlier, that is auto, extern, static, all these are actually stored in RAM. But in the case of register storage class, the CPU register is used for its storage purpose. That is why it is called register storage class. And it is similar to auto storage class in the sense it has got local visibility. The variable is limited to the particular block, local visibility. But the only difference is that the variables declared using register storage class are stored inside CPU registers, as I said, instead of memory location in RAM. So the variables declared using register storage class has no default value. No default value will be provided by the computer. So that means it is not initialized automatically. Okay. So this is an example of register storage class. Register int 8. It is just like automatic storage class, but the difference is only the CPU register is used for its storage. Thank you for listening.